To get started with Chapter 4, Appendix A, Present Value, Time Value of Money, go to your study plan in My Finance Lab. Then click on Chapter 4. Look for the problems that are the same as the ones that are assigned. For example, Problem 4A3 is one of our assigned problems in Chapter 4. So we'll click on that. Now I'll show you how to solve that using the financial calculator that I recommend at www.arachnoid.com. That's all you need to type in. In this problem, we are looking for the future value at the end of a given investment period. For example, we have an investment amount of $500. That is called the present value, or what it is worth today. We're assuming that we can earn 5%, and we are looking for the future value of this investment at the end of 18 periods. So in our calculator, we put in for the present value, we actually put in a minus 500. We use a minus there because it is a cash outflow. Number of payments, 0, because these are not annual type payments. There's just that one present value. Payment amount is 0. Oh, excuse me, the number of payments is 18, because that also stands for the number of years. Interest rate per period is 5, and the payment is assumed to be at the end of the period. Always assume that the payment is at the end of the period unless you are specifically told that it's the beginning. It's typically at the end. Okay, now we are looking for the future value of investment A. Click over here where it says Compute Future Value. Okay, it gives us a future value of $1,203.31. Enter that into My Finance Lab. And click Check Answer. Hey, well done. Let's do it again. For B, the investment amount is $3,500. That's today's value. So we enter in minus $3,500. The rate of return, 14%. That is the interest rate. We enter it as a whole number. The investment period is 8 years. So that's our NP, number of payments or number of periods is how I look at it. Payment amount, that would be for a recurring every year type payment, like a mortgage payment. We leave that at 0. We click on future value, and we get $9,984. Enter that, check answer. Okay, so that gets you started on the first one. Now I'm going to close this particular problem. Problem 4A4 is the similar concept. Problem 4A5 is looking for the future value of an annuity. And an annuity is when you put the same amount of money in every year at the end of the year. So I'm going to go to 4A5. And here's our example. It's an annual deposit. So every year, this person is going to put in $4,200 into the bank or whatever. Okay. Earn 12%, life is good, and 13 years. So you're going to expect the amount is going to be greater than 4,200 times 13, because that amount of money is going in every year, plus there's going to be interest of 12%. So over in our calculator, the present value today is 0, because there's nothing in the account today. they are going to make 13-period payments, and the payment amount is minus $4,200. This is an annual payment. It's put in as a minus because it's a cash outflow. And the interest rate per period entered in as a whole number is 12. Now we click, a lot of times I zero out the future value before I calculate. Then I calculate future value, $117,722.26. And I check my answer. Yay! And I can just go to the next problem, which is the same concept. If you deposit $900 into an account at the end of each of the next 7 years, and the account pays an annual interest rate of 9%, how much will be in the account after 7 years? Okay. You already should know that the answer will be greater than 900 times 7, or 6,300. Okay. So let's see, payment amount minus 900. Number of payments, 7. Interest rate, 9. Future value, compute, 8280. 6,300 is the amount that you put in over the years. But with the interest on the interest, you end up with 8280.39. So that gives you a pretty good grounding in calculating future values. We did two things: the future value of one amount carried out into the future, and the future value of an annuity, which is a series of equal payments at the end of each year. So I hope this helped.